of the AP Calc, practice test, you'll notice that in these questions, we are going to be allowed to use our calculators if we need to. All right, so let's look at number 76. We are told that the function is continuous on a closed interval 0 to 5, and it gives us the graph of the f function, the derivative of that. All right, and it wants to know on which of the following intervals is the original function increasing. This is really just a question on, do you remember when we went through looking at what the first derivative values will tell us about the original function, and the same thing about the second derivative values tell us about the original function. We already went over in a previous question that the second derivative values are going to tell us the concavity, right? Concave up or concave down. This is the same type of thing. Wherever the derivative of the function is positive, that is where the original function is increasing. Wherever the derivative of the function is negative, that's where the function is decreasing. So in this problem, I'm just looking to see where are my y values in my graph positive. So where are my y values in this graph positive? That's from 0 to 2 and from 4 to 5. Okay, 77. So this is asking for the velocity of the object at time t equals 3, and they give us the height. All right, so in this case, it's kind of like the position, velocity, acceleration discussion we've had before. In this case, the position is just the height. So to get the velocity, we're going to take the derivative of this height function. So the first thing I'm going to do is I'm going to find the derivative of the height function, which is 2t. All right, now what I did was I rewrote this in my brain as negative 16 times t to the negative first power. So when you use the power rule, you get plus 16 times t to the negative second power. All right, derivative of a constant is 0. So if we want to find the velocity at the exact moment at time t equals 3, we just use this derivative and we plug in 3 for t. All right, so I'm going to go to the calculator and I'm going to type in 2 times 3 plus 16 times 3 to the negative second power. So 2 times 3 plus 16 times 3 to the negative second power. All right, so the answer is 7.7 repeating, which in this case is 7.778. All right, 78. Now this one is asking about linear approximation, and it's been a while since we've done this. All right, but the way that we do this is we're trying to find the approximation for g of negative 1.2. So we first are going to say, okay, what's the nearest one to it? That's g of negative 1 plus the derivative evaluated at that negative 1 times, and this is where we're going to do negative 1.2, so we're trying to find minus how far away it is from the approximation that we're using, all right, or the value that we do know, which is negative 1. So let's plug in what we know. We know g of negative 1 is 4. All right, so this is going to be 4 plus the derivative is 2, all right, and then negative 1.2 plus 1, right? So adding 1 is going to give you negative 0.2. So that's 4 minus 0.4, which is 3.6. So we didn't really need a calculator for this one. All right, this question is asking about the average heart rate. So this is the average value of a function, right, which we've used before. The formula is 1 over b minus a times the integral from a to b of your function. All right, so if we're just kind of plugging in the stuff that we know, we're saying that we want to know the average heart rate from 30 minutes to 60 minutes. So I'm going to do 1 over 60 minus 30 times the integral from 30 to 60 of our function. In this case, our function is h of t. So if I match that up with my answer choices, I'll find that the answer is B. All right, number 80. Okay, so number 80 is asking about, do you remember the fundamental theorem of calculus part 2? All right, and essentially this part 2 that we talked about allowed us to find the value for a definite integral. So in this case, I'm trying to figure out the value of g of 5. So if I set up this definite integral from 2 to 5 of my g prime of x function, I can evaluate. I'm going to use capital G to show you that I'm doing the antiderivative. So g of 5 minus g of 2. All right, so because we have the calculator as an option for us, what we can do is that we can find what this is in the calculator. So I'm going to be plugging this in using my calculator to find that value. I also know that g of 2 is negative 7, right? They gave this to me. So now all I have to do is find my unknown value of g of 5, and I'm going to do that kind of second. So let's type in what I want to find in the calculator. So to do the integral, you go to math, all right, and then you scroll down to number 9. It's at the bottom there. So number 9, and the integral is from 2 to 5, and the g prime of x that I want to find the integral of is the square root, so second square root of x cubed plus x, so x cubed plus x, and then make sure you put dx here. All right, so that gives us the value there, 20.899. So this is, let me change back to my writing. So this is 20.899 equals, I don't know, right, g of 5, I'm trying to find that, minus, and this is, they told me is negative 7. So if I just, that becomes plus 7, so if I want to move that over, I'll just show my last couple steps here. So g of 5 plus 7, if I want to get g of 5 by itself, I subtract 7. All right, so if I subtract 7, then I get 13.899. All right, so the answer is C. All right, 81. Now this one is asking about removable discontinuity. We have 3 types of discontinuity. We have removable, which is you're thinking about holes. We have jump discontinuity, which is happening in letter B. And then the other one, infinite discontinuity, when you have asymptotes. Okay, so in this case, I'm thinking about where are they cutting out a hole and moving that piece somewhere else, and that is in C. All right, so that's kind of what I want you to think from when you're back in algebra. All right, so 81 is C. Okay, 82. All right, now 82, the way that I kind of set this up once I sorted out my brain was I'm looking at essentially different ways to get from 0 to 20. So the first one I did was the integral from 0 to 17 of f of x plus the integral from 17 to 20. All right, that would be the same as going from 0 to 13 plus the integral from 13 to 20. All right, and kind of like one of the problems we just solved a few minutes ago, is there are 4 pieces here, and I know 3 out of 4, so I can solve for that missing one. This value is 8. This value is negative 3. I don't know this one, right? That's what I'm solving for. And this one is 7. So this becomes 5 equals, I don't know, plus 7. So for this to be true, that would need to be negative 2. All right, and finally for number 83, before we stop for the next part, with this one, when we did this in class, it required a lot of work to do this algebraically. But because you know that the answer has to be one of these values or no such value, you can go ahead and use the technology to help you. So I just start by plugging in the first one for my k. So I go to y equals to graph, and I'm doing 2.081 cubed plus x. All right, that's my first graph. And the next one says 16 divided by, and then it's k squared minus x, so 2.081 squared minus x. All right, and I want to graph this. All right, and I can't see where they intersect, and if this is going to be true, then they should intersect at x equals 3. So I'm going to change the window here. So I'm going to change my window to do from 10 to 20. Oops, sorry. Yes, 10 to 20 for my y value so I can see. All right, so you can see there, it looks like there is an intersection. So I want to figure out what that intersection is. So I go to second trace. Let's see if I can do this. Second trace. There we go. Intersection. So 5. And the first curve is the blue one. Second curve is the red one. My guess is going to be around 3. There we go. I'll guess right around here. And you can see the intersection happens at 2.9983672, which is essentially 3. So this would show you that it's continuous if we use this value A as K. So that one worked out. If it didn't work out, I would just type in the next ones. And then if those all 3 didn't work out, I would pick D. All right, so that's it for this part. Tune in for the second part of using the calculator on these multiple choice questions.